So next I want to show you how we can actually break up peptide bonds through a reaction called hydrolysis. And so I'm going to back up one slide and just remind you that the peptide bond was formed through a condensation reaction that resulted in the formation of water. So we combined a carboxylate group and an amine to make an amide, and that was a condensation reaction that yielded water as a byproduct. Well, guess what? Hydrolysis is the reverse of condensation. And so that's going to convert an amide into a carboxylic acid as well as an amine. So really you could just draw the reaction exactly backwards, but I'll kind of show it here clearly. So I'll draw again a generic dipeptide in this case. So I've got my amine group, I'll have some R1 group, that's the side chain, and then we'll have the carbonyl, and then here is the nitrogen that is part of that amide functional group, that peptide bond, and then the other amino acid R2 side chain, and then the existing carboxylate. So here's a dipeptide again, and I'm going to show it how this would be degraded or hydrolyzed by water. So here's a water molecule. We'll see it could be water that does this. It could also be hydroxide that does this. We won't worry too much about those details. But just like before, I can zoom in on this, I will use one arrow to demonstrate a new bond, right? So make a new bond from the oxygen of water will form a bond to that carbonyl carbon. And then I'll have an old bond that's going to break. So the bond between the carbonyl carbon and the nitrogen is going to break to result in those electrons moving over to that nitrogen. And so we've got the oxygen here, and it's going to form a new bond to that carbonyl carbon, but we're losing the bond to the nitrogen. So what's that going to look like? So I'll put a reaction arrow, and then I'll draw our products. So I'm still going to have, from the left-hand side, the H3N, so that amine. I'm still going to have that R1 side chain. I'm still going to have the carbonyl oxygen, but instead of having that nitrogen, I'm going to have a bond to OH or O-, since we're probably doing this at physiological pH. This formed a carboxylic acid, which is going to deprotonate as shown. And then the other product then is the other side of that. That is the nitrogen now, which will need extra protons, and so it'll grab those protons essentially from water, if not here, then from other water molecules. And so it'll have then here our H3N, just like before, and then our R2 group here, and then our same carboxylate group that we had. So now we have broken apart the amide, and it is now in the form of this two separate amino acids. Here's the carboxylic acid, which is now a carboxylate, and the amine here. And if you wanted to, just to be clear, you could highlight the bond here in this color just to indicate that that is the new bond over here.